It really is amazing how fast AI is moving, isn't it?
It is. You blink, and there's something new.
Yeah, just when you think you've got a handle on things, boom, something comes along that, well, just changes the game, especially in really fundamental areas like maths, computer science.
Absolutely. And that's exactly what we're talking about today, I think. This new AI agent, AlphaEvolve from Google DeepMind.
AlphaEvolve,
It's not just using algorithms, it's actually creating them, optimizing them.
So it's like an inventor AI for code.
Sort of, yeah.
Yeah.
Think of it like that. It's trying to find new, better ways to do the calculations that underpin, well, everything digital.
Okay, AlphaEvolve. So break it down for us. What is it at its core? You said evolutionary.
Right. So fundamentally, it's an evolutionary coding agent. It uses Google's Gemini language models, the really powerful ones, to discover and improve algorithms.
Instead of just using the ones we already have.
Exactly. It's designed to come up with potentially brand new ways of solving problems or to seriously boost the efficiency of existing methods.
Okay, for anyone listening who really tries to keep up with the big AI shifts, this definitely sounds like one to watch. So what's our mission for this deep dive? What are we looking at?
Good question. We want to really unpack how AlphaEvolve works, what makes it tick, and look at what it's actually done so far, because some of the results are pretty remarkable.
Okay.
And then, why does it matter? What's the bigger picture for science, for tech? We're basing this on the details that Google DeepMind put out recently about it.
Got it. So the mechanics first. How does AlphaEvolve actually do this? What's the engine behind it?
Well, the core concept is really this marriage, this synergy between the creative side of LLMs, the Gemini models, and very strict automated evaluation.
Okay, creative LLMs plus robot judges.
Something like that. You can picture the LLMs just generating ideas, right?
Yeah.
Lines of code, different approaches to a problem. But then these ideas get immediately stress tested by automated systems.
So the AI suggests something, and another AI checks its homework, basically.
Precisely. It's all wrapped up in this evolutionary framework. LLMs propose code, automated checkers test it for correctness, for performance, and only the best ideas, the fittest ones, get fed back in to prompt the next generation of code. It's like natural selection, but for algorithms, happening super fast.
Wow. That's a powerful idea.
Yeah.
The DeepMind piece mentioned they use an ensemble of Gemini models, not just one. Why do that?
Yeah, that's a key part of its effectiveness. It uses a mix, Gemini Flash and Gemini Pro.
Okay.
Think of Flash as the rapid prototyper. It's super quick, throws out a huge number of diverse ideas, covers the breadth.
Right, casting a wide net.
Exactly. Then Gemini Pro comes in. It's got deeper reasoning, more analytical power. It takes the most promising ideas from Flash and really refines them, digs into the details.
So Flash for exploring, Pro for perfecting. Makes sense. But how does it know if one algorithm is truly better? How's that objective?
That's where the automated evaluation metrics are crucial. These are hard, quantifiable measures. Is it accurate? How fast is it? How efficient? It takes human subjectivity out of it. AlphaEvolve can rigorously test if a new algorithm works and how well it stacks up against the old ways.
So it's not just does it run, but how well does it run?
Exactly. Speed, efficiency, correctness. And that focus on measurable progress makes it perfect for fields like math and computer science, where you can clearly define what better means.
Okay, so we've got this code-inventing, self-checking AI. The announcement really emphasized its use inside Google itself, right? Optimizing their own huge systems. What's the real-world impact been there?
Yeah, this is where it gets really tangible. Google's actually been using AlphaEvolve discovered algorithms in production for over a year now.
Oh, really?
Yeah, improving things like data center operations, chip design, even how they train their big AI models like Gemini itself. The scale is just huge.
Can you give us an example? Where did it first make a difference?
One of the big early wins was in data center scheduling, managing all those computers efficiently.
Right, Borg.
Exactly, Borg. AlphaEvolve found this surprisingly simple set of rules, a heuristic that helps Borg allocate resources better.
And the result?
It's been running for over a year, and it's recovered, on average, 0.7% of Google's entire global compute capacity.
0.7%. That doesn't sound like much, but for Google.
It's astronomical. Think of the sheer scale. That's a massive amount of computing power saved, resources freed up.
Wow, okay. And they mentioned the code it produces is often human readable.
Yeah.
That seems like a big advantage, too.
It really is. Performance is one thing, but if engineers can actually understand the code AlphaEvolve generates, well, that's huge.
Why is it that?
It makes it easier to trust, easier to debug if something goes wrong, easier to predict its behavior, and just generally easier to integrate and maintain in complex systems. That interpretability is key for adoption.
Makes total sense. Okay, what about hardware? How does it help design actual chips?
Yeah, that was another interesting one. It helped optimize a specific circuit for matrix multiplication on one of their upcoming TPUs, their custom AI chips. It basically rewrote the Verilog code, that's the language engineers use to design chip circuits. It managed to remove unnecessary bits from the design.
Without breaking it.
Exactly. While keeping it functionally identical, it shows this really cool collaborative potential, you know? AI suggesting optimizations that human hardware engineers can then verify and use.
A partnership, almost. And it's speeding up their own AI models, too.
Yeah.
Training and running them.
Directly. Hugely important for things like matrix multiplication, which is just fundamental to models like Gemini.
Right.
AlphaEvolve found a way to speed up large matrix multiplications by 23%. That's a massive jump for such a core operation.
23%. And that translates to what?
About a 1% reduction in the total training time for Gemini. Again, sounds small, but given the immense cost and energy needed to train these giant models, 1% is significant savings.
Absolutely.
Yeah.
And it makes the process of finding these optimizations faster, too.
Oh, yeah. They said it cut down the engineering time for this kind of low-level optimization from weeks of intense human effort to just days of the AI running experiments.
Weeks to days. That speeds everything up.
Massively. Faster iteration, faster innovation.
And it goes right down to the GPU instruction level. That seems incredibly fine-grained.
It really is. That's normally the compiler's job. Humans rarely touch that level directly. But AlphaEvolve got up to a 32.5% speed up on the flash attention kernel.
Flash attention. That's crucial for transformers, right?
Exactly. Underpins so much modern AI. So optimizing that, even in ways humans hadn't spotted, is a big deal. It also helps the experts see where the bottlenecks are and improve the core code basis.
So it's not just handing over code, it's providing insights, too. Very cool. Okay, let's shift gears a bit. The announcement also talked about more theoretical stuff, pure math, finding new algorithms from scratch. What's happening there?
Right. This is where you see its potential to really push the frontiers of, well, knowledge itself. It's not just tweaking existing things. It's proposing fundamentally new approaches.
Oh.
You give it a minimal code skeleton, basically just outlining the problem, and it can generate significant chunks of completely new algorithms or optimization methods.
And it's tackled some classic problems, like matrix multiplication again.
Yes, exactly. A cornerstone problem. AlphaEvolve found several new ways to do it. The big one was finding an algorithm for multiplying 4x4 complex matrices using only 48 scalar multiplications.
48? Is that good?
It's better than the best-known method since 1969, Strasson's algorithm. So yeah, an AI just broke a decades-old record in fundamental computation.
Wow. Okay. How does that compare to AlphaTensor? I remember that making waves.
Good point. AlphaTensor was amazing, but its best results for 4x4 matrices were limited to binary arithmetic, just zeros and ones. AlphaEvolve doing this for complex numbers, a big step up, much more generally applicable.
I see.
And it wasn't easy. The paper mentions it took like 15 distinct mutations in the evolutionary process to find this new algorithm. These weren't trivial tweets.
15 steps. Okay.
Yeah.
So beyond matrix math, have they tried it on other mathematical puzzles?
Oh, yeah. They threw it at over 50 open problems across different areas: analysis, geometry, combinatorics, number theory, you name it. Pretty impressive results. In about 75% of cases, it rediscovered the current state-of-the-art solutions. Things mathematicians had figured out over years, AlphaEvolve found independently.
That's quite a validation, isn't it? That shows it can navigate that complex space. But did it find anything new? Did it beat the humans?
It did. In about 20% of the cases, it actually improved on the best-known solutions. Push the boundary.
Like what? Any examples?
Yeah, the kissing number problem.
The kissing number. Okay, you have to explain that one.
Yeah, it sounds funny. It's a classic geometry problem. How many identical spheres can you arrange so they all just touch a central sphere of the same size without overlapping?
Well, okay. Like arranging billiard balls around a central one.
Exactly. But in higher dimensions, too.
Right.
It's been stumping mathematicians for centuries. Well, AlphaEvolve found a new configuration in 11 dimensions.
11 dimensions, okay.
It found a way to pack 593 spheres, which set a new lower bound, a new record for that dimension, a genuine advance on a really old, famous problem.
So from optimizing Google's data centers to advancing 11-dimensional geometry, that's quite the range. Where does AlphaEvolve go from here? What's the vision?
Well, you see the progression, right, from very specific computational tasks to finding broader algorithms for bigger challenges. The thinking is, as the underlying LLMs get even better at coding and reasoning.
Yeah, AlphaEvolve gets even more powerful.
Exactly. Its potential just keeps growing.
And will it stay locked up inside Google? Or are they planning to share it?
They mentioned plans to make it more accessible. Apparently, the People Plus AI research team is building a user interface for it.
Oh, interesting.
And they're planning an early access program for academics and looking at ways to get it out more broadly after that.
That could be huge for researchers everywhere.
Yeah.
And the potential uses. They're not just math and computing, surely.
Oh, absolutely not. I mean, think about it. If you can define a problem algorithmically and you can automatically check if a solution is good, then this approach could work anywhere. Material science, discovering new drugs, sustainability problems, maybe even business processes, the list goes on.
Right. Anywhere you need a better process or a new solution.
Pretty much, as long as you can measure success.
So wrapping up, AlphaEvolve feels like a really significant step. It's AI moving beyond just processing data to actually generating novel solutions for really hard problems.
That's the key takeaway, I think. It's this powerful mix, this sort of unbounded creativity of LLMs harnessed by really rigorous systematic testing.
Yeah.
And it's leading to concrete wins, optimizing massive systems, but also making fundamental scientific discoveries. It's one of those aha moments where different AI capabilities come together in a really potent way.
And the potential ripple effects across, well, almost any field.
Yeah.
It's pretty mind-bending. Makes you think, doesn't it?
It really does. I mean, if an AI can find new mathematical proofs that humans missed for 50 years and optimize systems at Google's scale, what else is out there? What other problems that seem completely intractable today might suddenly become solvable?
It definitely forces you to rethink the boundary between human smarts and machine intelligence in that search for, well, for progress, for answers.
A fascinating question to ponder, for sure.